We'll start today's session, and today's session is based on collections framework. So, what is the need of collections framework? You already have knowledge about arrays now, right? And you also have knowledge about data types. So, you have seen both the data types, like primitive data types, and as well as we went over this wrapper classes, right? So basically these data types are used to hold some values. Suppose you want to hold some integer values or double values or string values, so you have those primitive data types. And if there was already primitive data type, then why wrapper classes were used? So wrapper classes can basically hold your null objects as well. Suppose you have not defined any value and you have like null value in that particular data type, so wrapper classes can hold your null values as well. And there was a special significance for wrapper classes, that wrapper classes are heavily used in collections framework. Now the question arises, like, why do we basically need collections framework if we already have like arrays, and arrays can hold like different primitive data types. Like you can have an array of integers, you can have an array of strings. So why was there a need of collections framework? So basically there's a need of collections framework. Like collections framework are uh, like based upon our use, that collection framework, any data structure that we use, that can be like extended. Means when you define an array, you basically create an array and provide some size to that particular array. So that array is basically fixed in size. So what happens if you want to use if you want to like increase the capacity of that particular array, then you need to like create a new array. But any collection framework data structure, take for example, you can take array list, sets, maps, queues, anything. They are like, they can like grow in size on their own. You don't have to basically uh, increase the size of the collection framework data structures. So that is why this collection framework came in picture. And these have like a wide variety of libraries. Like there are like different types of collection framework objects that you can use for different purposes. So we'll go through one by one. Let's see what this module basically covers. We'll go through the introduction to collection framework, and then there were some legacy classes in collection framework. So when Java 1.4 or 1.3 was there, means initial versions of Java was there, so a lot of legacy classes were used. They are still used, but they are like used in very old projects, so they are not like popular in today's world. So if anyone basically starts a project or a real-time project, so they will not basically use these legacy classes. So this is not very important as of now, but we'll go through all the collection API and its components. Like there are a lot of data structures here, like lists, sets, maps, queues, dequeues, stack, iterators. So I'll just give a brief about each of them and then we'll start one by one. So list is basically similar to your arrays. So it is like it can be a list of integers, it can be a list of double values, it can be a list of basically your string values. And you can also like create a list of objects. Suppose you have created a list of employee, you have an employee object created which has id and name. Suppose it has two attributes like id and name, and you want to create a list of employees, so you can create a list of employees as well. Means user defined objects can also be uh, contained in this data structures. Similarly, why do we basically need sets? So when we say set, so set basically holds your unique values. So if you like add a lot of numbers in the sets, so sets will basically determine the unique values. So it will not keep any duplicate values. So that is the importance of sets. So whenever you have such a requirement that you want only unique values uh, in your return set, so you can use go for sets. And then there are like maps. So maps are basically kind of dictionaries. So these are like kind of key value pairs. So when I say key value pairs, suppose you want to associate uh, any person with marks. Suppose say Jacob got 80 marks out of 100. So you want to like associate Jacob 100. So that means that Jacob has got 100 marks. Let's say John has got 95 marks. So here John and Jacob are basically the keys, and the values corresponding to those are their marks. So similar is the use case. When you want to create something like a key value pair that or a dictionary kind of thing, you'll basically go for maps. Then there comes like another data structures like Q and DQ. So Q you understand by the general in general sense, what do you mean by Q? A person comes, and suppose at a ticket counter a person comes, and then there is another person following that person. So what happens, any person who wants to purchase a ticket comes and stands in the queue. So it is like a queue. So and the first person purchases the ticket and he moves out of the queue. Then the second person purchases the ticket and he moves out of the queue. So whatever whoever comes first like goes out first. So in Java we basically call this as first in first out. So whoever came in queue first goes out of the queue first. So that is called a FIFO. That terminology is called FIFO, FIFO, that is first in first out. Then we have something called DQ. So DQ is a extended version of queue. So basically this is kind of a data
Hey, how you
structure.
doing?
Yes.
Okay. Who's that? Okay.
Can
Yeah.
you mute yourself? Yeah. So I was speaking about DQ. So DQ is basically an extension of the queue. So it is kind of like doubly ended queue. So in queues, basically the insertion happens at the rear. So basically whenever a person comes, he joins at the rear end or at the end of the queue. So in DQ, you can basically perform operations at both ends. Basically, this is kind of a data structure which is like opened at both ends. You can add elements at the beginning, you can add elements at the end of the uh, DQ as well, and you can like remove elements as well from both the sides. Like you can remove elements from the beginning, you can remove elements from the rear end as well. So these are the uses of DQ. Now there is another data structure which is stack. Stack is basically, when I say stack, I can say like a stack of plates or a stack of books. So you have kept one plate, then you keep another plate over that plate, and then another plate over that plate. So you basically stack one plate over the other. So what happens when you remove one of the plates? So you will basically remove the plate on the top. So what happens, suppose you have like five plates. Plate number was one was kept at the bottom. Then plate number two was kept over it, then plate number three was kept over it, and then plate number four was kept over it, and five over it. So when you basically try to remove any plate, you will basically remove from the top, right? You go in a buffet and basically try to take the plate from the top of the stack. So that is the use case. Whatever was placed at the last will be removed at the beginning. So what happens, this is called LIFO, or last in first out. So whatever is placed at the last is basically removed at the first. So this is about stack. And then we have something called iterators. So iterators are basically used to iterate over these data structures. Suppose we have created a list of suppose we have in our list we have like 100 elements. List of integers contains like 100 elements. So we want to basically iterate over it. So there are like iterators. These iterators will help to iterate over these data structures. So we'll go through these iterators, how we can use these iterators to like traverse the elements. And then we will have some comparative study. And then there is one collections utility class as well. This collections utility class basically helps us to perform some operations, like you can shuffle the order of elements. You can like perform some kind of sorting, like you can perform some ordering of the elements. Like if you want to arrange the elements in ascending order or descending order, so you can use this collections framework. And there are like various other functionalities as well, but we'll cover this when we go through when we deep dive through this collections utility class. So this is basically about the introduction of collections. So let me go through the next slide. So collection API. So it's a unified architecture to cache objects heavily. So these are the collection. So basically we'll go through collection, iterators, map. So collections are used to store and organize set of objects, and the set of objects can be of various types. Like it can be like integers, it can be strings, it can be like any object type as well. When I say an object type, basically it contains like it contains your user defined objects. Like suppose you created an employee object or a student object, so you can have collections over those things as well. So it depends upon our need or the scenario in which collection class can be used. So based upon your requirement, you need to like decide what collection data structure or what collection framework you want to use. Suppose you have a scenario where you want to like use means store a list of employees. So what you will basically do, you can use a list interface. So I'll let you know what is list and what is array list, and those things when we talk about each of those collection framework entities in detail. But based upon your requirement, you will need to decide like which collection framework entity you will use. So all this list, sets, maps, whatever we have discussed, these are like contained in java.util.package. So whenever you create any list or array list or sets, maps or anything as such from the collection framework, you will see in your editor that and automatically this java.util package is imported. So you have your imports in the class, right? So there you will see this java.util.package is imported. So this package offers the variety of classes and interfaces which comprises the collection framework. So as compared to the STL library of C++, this framework contains rich set of interfaces and their implementations. So if anyone has already some knowledge about C++, so there is some STL library which works similar to this. So this framework contains rich set of interfaces and their implementations. So when I say interfaces and their implementations, what I mean is like interfaces are basically contracts, right? And implementations are basically provided by the class. You have already seen the topic interfaces, right? So what was done in interfaces? In interfaces, basically there are some abstract methods, and those abstract methods are basically provided definition. Those are like implemented by some classes, right? when I went through that topic interfaces, I have shown you how you can basically create uh, some interfaces which only contains some abstract definitions, and those are just prototypes, and some class which implements that particular interface has to basically provide the implementation for that method. Suppose I have one interface called animal, and there is some class such as say lion which implements that. So whatever methods were there in that particular interface, that lion class has to provide some definition for that. So that is like implementing, like providing functionality to the prototype which we defined in the interface. So we can say that interface has some prototype, and that class is basically that class basically needs to like implement those contracts. So a class and an interface are connected. Interface holds some methods, and those methods definition are basically given in the classes. So you can like relate these things. When I show you the collection hierarchy, I will show you the map. So at that time you will be basically able to relate how these things work, like how the interfaces are defined, and like which classes will be basically providing the definition over that. So collection is for caching objects only, while map provides a mean for maintaining key value pairs, so that quick and efficient lookup for values on given key is possible. So there is like another data structure like map. This is in collection framework. This is for getting your key value pairs. So key value pairs are basically in the form of dictionary. So arrays can store primitive data types. Collection can store objects. So arrays we have seen, right? It can store only primitive data types, and also arrays can basically arrays, when you create an array, those are like fixed in size. Once you provide some size to that, those are fixed. But collections have some advantage, like those can store objects, and those are not fixed in size. Based upon your requirement, those collection entities will uh, grow in size automatically. You don't have to basically provide some size or increase some size. So that is how this collection framework works. And then there are like iterators. Iterators are used to traverse through a collection. So traversing means going through a loop kind of thing. So you have seen how basically if an array holds like 10 objects, if an sorry, if an array holds some 10 values, so you can basically write a for loop or a while loop or a for each loop, and then you can like traverse through that array, right? You can like print out each of the element. So similarly, you can also use a for loop or while loop to print through the collections. But this collection framework has basically provided an iterators kind of thing. So we'll see how these iterators can be used to traverse through a collection. So let's go through legacy class. This was one of the legacy classes. So there is this vector class. So I'll not give the demo of this because this is like legacy class and this is like very seldom used now. But all the other data structures other than this legacy class, I'll provide the demo. So just see this. What they have done is like they have created this vector v is equal to new vector, and then they have provided two values, and then they have like printed out this. So in this vector, basically you can add values like this: v dot add I. Yes, Solomon, STL is standard template library that was in C++. Yeah. So this vector, basically we are running a loop, and then we are adding elements in this. And then what is, you can like insert element. So let's say you want to insert element at some particular index. So you can provide the index, and what value you want to basically uh, add, you can like provide that particular value. So see, after inserting element at position 23 v, so what you basically did was v dot insert element at, so 30 is the value inserted and it is inserted at position 23. So say this vector, this vector had a had some size, and at particular index, at particular index like 23, you are inserting a value 30. So we are doing this like this, v dot insert element at. So this is how you can like insert an element. Then we have something like v dot contains 10. So you want to like check if this particular data structure contains this value 10. So you can use this function v dot contains 10. So this is about this legacy classes, and then we are using some enumeration object to traverse through this. Just see this enumeration e, and then we have written a for loop, and e is equal to v dot elements. So initially we this v dot elements give us the size, and e dot has more elements. So e dot has more elements is like if this vector still has any elements to traverse, then we'll print it. If it has, we have printed, and then we are going back to the next element. So again we'll print the next element, and again we'll check whether this vector still has any more elements. So we'll keep on printing that, and at the end if we reached the last element, then we'll basically move out of the loop. So this is basically about enumeration, how this enumeration can be used to traverse through the vectors. So these are like legacy classes, and these are not very much used now, so I'll not give the demo of this one. But other classes like and other libraries which are basically used heavily in collection framework, all those demos will be seeing now. So see this collection hierarchy, this is our modern collection hierarchy, and this is like heavily used. This will, when you create your real-time projects, you will be like using this like day in and day out. And this topic is also very much important with regards to your interviews. So kindly focus like on each of these are like very important. This collection hierarchy is very important. So see, when I gave you the introduction of a collection framework, I talked about set, list, queue, and I also talked about maps, right? So see, collection is the interface. So collection is the interface. If you see this hierarchy, collection is the interface, and these interfaces like set, list, queue, these are also the interfaces. So there can be like different types of sets. So can anyone tell me like what are these hash sets, linked hash sets, and tree set? If set is an interface, what is this hash set, linked hash set, and tree set? Can anyone tell me? So suppose this set is an interface, it holds some method prototypes, right? So there must be some class which needs to implement this set, right? And that needs to provide some definition to that, right? So this hash set, linked hash set, and tree set, these are basically the implementation classes for this set. So when I talk about this set, this is an interface, and these are basically the classes which will be providing the implementations for this particular set. So similarly, when we talk about this list interface, list is an interface, and all the methods which are in this particular interface, their definition is provided by these classes, and these are like implementation classes like array list, vector, linked list. So This provides the definition of the methods in the list interface. So similarly, see this queue interface. This queue interface is another interface, and there are different implementation classes for this. There is like linked list. So the definition of this can be provided by the linked list class. And similarly, this priority queue is also another data structure which provides the definition of the queue. And then there is like another DQ. DQ is, we talked about DQ, right? DQ is basically doubly ended queue. So doubly ended queue, and it extends the queue. So whatever functionality queue interface has, DQ has added some functionality to that particular interface. So DQ is also an interface, and the implementation class for DQ is basically array DQ. Anyone has any questions over this hierarchy? If you have not understood, basically it's important to understand, then we'll go through the code. Because if you don't understand the hierarchy and why we are basically using each of these, then means you will understand the code, but you will not understand why and which data structure which we will be using upon requirement. Let's talk about the set interface. So I told you, like, right, like set interface is basically required when you do not want to have any duplicates in your data collection. Let's say you want a collection of some objects where you don't want to have a duplicate. So in that case, you will basically create a hash set. You will basically create a set, and there are like three implementations of set, like hash set, linked hash set, and tree set. So what this will basically do, when you have some elements in your set and you have a hash set, let's say that particular hash set is used to store some of the values. So when you print out this hash set, right, the elements can be printed in random order. Suppose you added some values like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the set. So when you print out the hash set, that will basically print out the elements in any random order. So this is about hash set. When I talk about linked hash set, so linked hash set, so linked hash set is basically used when you want to preserve the order of insertion. So what I mean by preserving the order of insertion is, suppose you have entered 1 first, then 2, then 3, then 4, and then 5. So in the order that you have entered elements in the set, in the same order that will be printed out. So that is like preserving the order of insertion. So whenever you have such a requirement that you want to insert elements in some order and you want that those elements to be printed in the same order, you will use this linked hash set. Now let's talk about this tree set. Why do we need a tree set? Suppose you have like 100 elements, and say the first element is 100, second element is 50, third element is like 150, fourth element is like 10. So and you have like similarly 100 elements, and these elements are in any order. But when you want the output, what you want to do is you want them arranged in some order. So you can basically go for a tree set. So this tree set will basically uh, provide an arrangement to those numbers. It will print out the numbers in the ascending order. So if you have such a requirement, you will be using tree set. Now you have another interface. Let's say we have list interface. So list interface implementation is provided by array list. So array list basically you will use when uh, this is like array list is like similar to arrays. So you start adding elements in this array list, and then you want to like print out the elements at any index. So it is like similar to arrays. You have like inserted elements in some order, like one after the other you have inserted elements in the order, and you can get any element index, means you can like randomly access through that particular collection. You want to fetch the element which was like stored at index 10, so you can like get the element at index 10. So this is about array list. Sometimes you don't want to get the elements in random order, so in that case you want a data structure or the collection framework entity like linked list. So linked list is basically you have some element, and then it is like linked to some memory address, and then there is like another linked object which is like linked to the first element. So when you traverse through that particular linked list, right, you need to like traverse through one by one. Like first linked list element needs to be traversed first, and then followed by the second, and then followed by the third. But there is one catch here. You can insert element at any place in linked list. You can insert element at any place in the linked list. So this is like an interview question. What is the difference between an array list and a linked list? Some interviewers might ask you like, what is the difference between this array list and linked list? So you can basically say that whenever you want random order of access, that whenever you want to access any element randomly, basically you can use array list in that case. And whenever you want to basically insert or remove element randomly, you can use linked list. So linked list helps you to insert element at any position and remove elements from any position, and array list basically helps you to traverse elements randomly, means you can fetch any element randomly. And one more thing, in array list basically you will insert elements in order, like you will insert an element at index 0, and then at index 1, and then at index 2, and then at index 3. But in linked list you can insert element like at randomly, like you have some linked list which holds your elements like 1 2 3 4 5 6 7 8 9 10. So you can choose to insert any element after 5. So that is like random order of insertion is possible in linked list. And but linked list, when you want to like traverse the linked list, you have to basically traverse in a sequence. So that is one constraint in a linked list. So you have to understand that whenever you want to randomly access any element, randomly fetch any element, you want to use array list. And whenever you want to randomly insert or remove any element from a list, you will go for a linked list. So this is one of the important interview questions. This can be asked. And now there is like another difference between this set interfaces. Like why do you want to use hash set, why do you want to use tree set, and why do you want to use linked hash set? So if you do not care about the output, order of the output, if you do not care about the order of the output, you can basically go for a hash set. If you want your output to be printed in the same manner in which it was inserted, you have to go through a linked hash set. And then there is this sorted set whose implementation is provided by tree set. So if you want to print out the elements in an order, so you will go for a tree set class implementation. So these are basically the differences. Now let's talk about queue interfaces. So I have already explained you the scenario where a queue interface is required. So suppose you have some FIFO kind of structure. What I mean by FIFO is first in, first out. So if you have some requirement where you want to insert any object, insert any element which needs to be like inserted first, and then that element itself has to be removed first, so you can go for a queue. And the class which will be providing implementation for that is a linked list. And then we have some another data structure or collection called as priority queue. So priority queue is basically like prioritizing the order of output. So we'll see about this priority queue in detail later, but this is about prioritizing any element to be printed. So we'll see how we can prioritize the order when we go over the demo of this priority queue. And then we have talked about this DQ. DQ is basically doubly ended queue. You can perform insert and removal operations at any ends. And the class will be which will be providing implementation for this is ArrayDQ. So this is about the collection hierarchy. You have any questions about this diagram? Okay, let's see about this collection interface. So see,
Britam,
yes,
from collection hierarchy. Yeah. Which means we have the interface collections. So below that, the arrow indicators. For example, linked list. It indicates interface queue and interface list. So which means without this linked list and array queue, there is no interface queue, or as the same as without array list, vector, and linked list, there is no any interface list.
yeah, see,
So for my understood like that, API interface. So we have API lead connected system, process, and experience. So like that, and for my understood, it is a difference or the same as?
okay, let me explain. So see, list is one interface, queue is another interface, and list holds some method method contracts, right? So queue also holds some method contracts, and linked list can provide definition to both the interfaces. Like it can provide implementation to the list interface methods as well. It can provide implementation to the queue interface methods as well. And when you like use a list and you want to like provide a linked list for its implementation, so linked list will only provide implementation to those methods which are defined in a list interface. And when you like use a queue interface along with a linked list implementation, so linked list will only provide implementation to those methods which are defined in the queue interface. And similarly we have like priority queue. Okay, let's talk about priority queue separately. But this linked list implementation class, this can provide definition to both list interface and queue interfaces. But it's like when when linked list is used for implementation of list interface, it holds the contract of only the methods which are defined in list interface. So linked list basically has like both the methods. Like it can have methods to which are related to a queue, and it can also have methods which are related to a list. But when a linked list is used with a list, it will only you will only able to get the methods which are implemented by a which are there in the list interface contract. And when it is used with the queue interface, it will be basically implementing only those methods which are in the queue interface contract. Is it clear?
Yeah, but can we see the demo each by one?
Sorry.
Yes, so can we do each by one as a demo?
Can we do each?
Yeah, example.
Yeah,
Can
yeah,
we
yeah. I'll show you the demo and example of each of these. Of everything means I was just going through the hierarchy, and once we see this, right, I'll show you the demo, and then it will be like very clear. So this is just about the hierarchy. That once you understand the hierarchy, implementations will be easy to understand, and also the use cases when we want to use each of those, right? So then it will be like more clear.
okay.
Okay, I'll show you another. Let's go through another slide. See, now we have this collection interface. So this collection interface will basically provide you methods, and these methods will help you to basically perform different operations in your collection framework objects. So you have like method to add. Suppose you want to add anything to your data structure, so you have method to add. Then there is like another contains method. This contains method is basically if you want to see whether your data structure contains this particular element, then you can use this contains method. And I've already talked about this iterator. This is used for basically iterating through your objects. So if you want to like iterate through suppose list or a set or a stack, you can basically use an iterator. So we'll see the implementation of each of these. And size method. Size method basically helps you to know how many elements are currently held by your collection. So if you want to check like how many elements are there in the array list, how many elements I have inserted. So suppose you inserted 10 elements. If you do collection dot size, it will give you the size of that. Like currently it is holding 10 elements. Then there is like another remove object, a remove method. So remove, if you want to like remove any element from the collection, you can use this collection dot remove. We'll see how we basically remove when we go through each of these collection entities. Then there is a to array method. So if you want to like uh, convert anything to array, any collection object to an array, that also we can do. We'll see how we can do that as well. So let's go through this list interface now. List interface, then when you implement the list interface, these are the methods which are basically available in the list interface, like index of any object. If you want to get the index of any object, you can provide that particular element, and then this will let you know what is the index of this particular element. And then there is like this get method, remove method. Okay, let me go through this demo directly, then it will be like more clear. Let me open my editor. Okay, I'll create one package. Okay, I'll create sub packages in this such that we'll go through lists first, and we'll go through array list first. Okay, just give me a second. Yeah. Okay. Okay. Yeah. Solomon, can you give us a little bit definition is to understanding if you can? Yes, Solomon, we'll go through the definitions as well. Okay, and linked list class is doubly linked list. Yeah, Solomon, linked list implementation that is provided here in collection is basically of a doubly linked list. Yeah, I'll provide you definition to each of those. Means I'll explain like all the scenarios and what is basically used when. So you'll come to know about it. Okay. Okay. We're going through the list interface. Okay. So we have one package created like collection framework dot lists. So see, list interface basically holds some methods like index of, which will basically give you the index, and then you have like methods to get and remove and then to iterate. So see, let me create one uh, class which will basically provide a array list demo. Okay. Okay. So we have seen that collection hierarchy, right? Where list can be basically implemented using different implementation classes. Like it can be implemented by array list, it can be implemented by linked list as well. So let's see how we can use a list. So I'll create a main method, and what I was talking about like at that point of time, like how you can use a list and the implementation can be provided by an array list. Suppose you want to create a list of integers. So see, as soon as I created this, I started writing code at line number 9, right? You can see this imported library at line number 4. So this is basically imported from the util package, java.util package. So java.util is the package and this is the class imported. So list is basically the interface. Now let's say I write down like list of integers and I create something like this new array list. So this array list is basically providing the definition of that. So this list is an interface and this class array list is basically providing the definition. You can similarly do something like this as well. List of integer and then let's say list. So you can do something like this as well. New linked list. See, I have the same interface, right? I have the same interface list and two different classes are providing the implementation. Two different classes are providing the implementation. So based upon our use case, we will decide what is our requirement. If we want to like randomly access the elements, we will go for an array list. If we want to like randomly insert or remove elements from a collection, we will go for a linked list. So let's see array list now. So suppose I want to add some element into this list of integers. I can simply do this like list of integers dot add. Let's say I have added 10. Again list of integers dot add. Let's say I've added 20. Now similarly, so we have added, suppose, say 6 elements in this list of integers. So this is a similar, so I've added 6 elements in this list of integers. So let me print out the size of this list, size of list. So what I will basically do, list of integers dot size. So this will give you the size. Now what you want to do is list of integers dot, let's say I want to print out element at index 3, let's say something like this. List of integers dot get. So what you can basically do, you can provide the index. So this will fetch you the element at that particular index. Now let's see, we'll see more things. What you can basically do, list of integers dot, suppose you want to add element at particular index. You want to add element at some particular index. So let's say at index 4 I am adding some element. Let's say I am adding 100. Okay, I will need to remove this print here because I am adding something. Okay, now what I want to basically do, I want to check the size again. So I can check the size again. Let me first try to run this one. See, when I created this list interface, I provided the implementation of this array list. So list interface implementation is being provided by array list. I'll just write some documentation here. So list interface implementation is provided by array list class, and random access of elements is possible using array list. So see, we are randomly able to get through the elements, means I am able to get any element randomly by using this method, list of integers dot get 3. So at index 3 we had this particular element, right? I had 40 stored at index 3, so I was able to get that. Now list of integers dot add. So what I basically did, at index 4 I inserted one more element. So initially the size of this collection list, right, it was 6. When I inserted one more element, means at index 4 I'm inserting one more element like 100. So the size has grown on its own, right? So the size of list has now become 7. Now let's say I want to print out, I don't want to like print out one by one, I want to like print out all the things at once. So what I will do, I can do something like this, and I is equal to 0. And how long we need to like print it, want to print it until the size of this list of integers. So what I will do, I want to traverse until the size of this collection. So list dot integers dot size, and I'll do something like this, I plus plus. So I want to print out each of this. So there's a get method. So in the get method, I need to provide the index. So I can provide this I. I is basically taking the index, right? So from index 0 to index 6, I will be traversing and I'll be printing out all the elements. Let me provide a space here. So once you run this one, see, you can see 10, 20, 30, 40, 50, 100. See, I have inserted this 100 later on, right? At index 4, I inserted this 100. So the size has grown now to 7. So this is like traversing through for loop. Traversing through for loop. Similarly, you can use a while loop as well. But let's see this for each loop, which are like more common. For each loop. So what you can basically do, you can write a for each loop. You can write something like integer x, and you can write a list of integers, and you can simply print something like this. So this is like for each loop is like very much useful while traversing through the collections. You don't have to basically write this entire for loop and this in condition and this increment decrement operator. You know that your list of integers is basically holding the data type integer, right? So you can simply write down something like integer, the data type you are expecting, some variable, colon, the collection framework entity. So when you print out something, list dot, okay, you don't have to do this, you just have to do x. So let me separate out this. Let me try to print out this one. See, using for loop as well, you are able to print this. For each loop as well, you are able to print this, right? So see, using for each loop, this is like more convenient to print this. Apart from using this for each loop, this is more convenient to use this for each loop. So for each loop is very useful in traversing through the collections. So this is like one method. Now we'll see like another method as well. Let's say I have iterator. So see, when I was writing through iterator, you would see a lot of things, right? There is one java.util, and then there is this java x.swing. So you need to like select this java.util because all the collection framework objects are basically in this iterator class. Sorry, all the collection framework objects are in this util package, java.util package. So I will provide down this integer itr and then list of integers dot iterator. So you need to write down something like this iterator and then provide the data type itr or any variable you can write down and list of integers dot iterator. Now I'll use a while loop, while itr dot has next. So what it does is basically it will check if there are more elements to traverse. So while itr dot has next, so when I want to like print it out, I will just print it out something like this, and I will do something like itr dot next. So itr dot next, basically it is like some kind of cursor. So this will like print out an element and it will move to the next element. So see, this is like checking a condition. If our collection, if our cursor is like pointing to some collection, and if there are like any more elements left to be traversed. So if there are any more elements in this collection, then this will return true, or this will, otherwise this will return false. So we'll see through this. Let me try to print this again. See, we are again able to print this using iterators. This iterators is also very much common in collections framework, using iterators to traverse the list. So we have seen three ways in which we can like traverse through the list. So first was like this for loop, another was this for each loop. This is also very common, and then you can use this iterators. Iterators are like similar to your cursors. Suppose there is kind of a pointer pointing at index 0, so you have printed that and again checked the condition if there is still any element in the list to be traversed. So if the list is holding more elements, then it will print out that. So itr.hasNext basically checks if there are more elements, and then itr.next basically prints your element, and then it moves out to the next element. Now there are more things you can like do with the list.integers dot remove. Let's say you want to remove some element. Let's say you want to remove the element 100, and now you want to basically again print out the size of this. You want to print out the size again. So let's print out this one. Okay, okay, we have to provide the index here. Let's say I want to remove something at index 4. I have removed some index at some 4. Now see, after printing this, I have removed one of the elements. The size was initially 7, and now after removing the element, this is size has decreased to 6. So whatever was at index 4, like 10, 20, 30, 40, 100. So 100 was at index 4. So if you like print it out now, so basically 100 won't be there. So let me try to print that out again. See, now 100 is removed, right? 100 is removed, but because at index 400 was there, and I was able to remove it using this method list of integers dot remove, and I provided the index, so I was able to remove this. So these are some of the methods in list. You can like explore more methods if you do something like list of integers dot. So you will see like a lot of things: remove, get, add, size. So you have already seen these things, right? Size, add, remove, add all, contains, object, So let's say we will print this. List of integer dot contains 10. So it will return me true or false. So this will return a boolean value. See, I'm able to get the value as true, right? Because 10 is contained in this data structure. 10 is contained in this array list. So that is why it returned me a value of true. So you can go through like just to a dot, and then you can like go explore through these methods: replace all, retain all, sublist, equals, last index of. Let's say you want to get the last index of, let's say 20. Suppose say I have inserted one more 20 here at the end, and I want to get the last index of 20. So last index of 20 is basically if there are like two objects which are like contained here. So last index of 20 will basically give me the very last index. So see, 20 was at index 1 as well, and 20 was at index 6 as well. So when I do something like integers dot last index of, so this will give me basically the last index like 6. So this is like about this list. So as of now in this example, I have implemented list interface using the ArrayList class. So I've used ArrayList class to implement the list interface methods. So do you have any questions in this one? So if one data structure is clear to you, right, other collection uh, classes will be like similar. It will be like easy because all the collection classes more or less contains the same methods. So it will be like very much similar. Okay, I'll create one more demo here. Let's say I create some employee class. So I'll show you we can do something like this as well. And let's say this employee class has two attributes like ID and name. And I have generated a constructor for this, and I'm also generating the getters. Okay, now let's say in this main method what I'm doing, I'm creating employee E1 object, and I'm providing the ID and name. Similarly, I'm creating more objects. Let's say E3, E4, E5. Let's say I've like created 5 objects of this employee class. Now what I want to do is list. I'll create one list of employees, list of employee, employee list, and let's say I have this array list, employee list dot add let's say I will add this even. So what I mean to say is basically you can deal with objects as well. Like you have created user defined objects and you are able to add those here. Now what we'll basically do, I will traverse this through this for each loop. So I know that if I traverse through this employee list, so this contains, like, this employee list contains 5 objects of employee, right? Since I've added 5 objects of this employee, this contains 5 objects. So whenever I traverse through this employee list, I will get one employee object. So first time what I will do, employee list, and let's say I want to print out the ID e dot get ID. And everyone able to follow this one, or you have any queries? E dot get name. So let me try to run this one. See, I'm able to print out like IDs and name by traversing through this employee list. So you can similarly use it to like create other type of objects, and similarly you can use this. One more thing, here whatever list I have created, I have used a list interface and provided implementation with the help of this array list class. You can also choose to do something like this. You don't have, have not provided the list interface, means you have a class and you're simply implementing, you are simply creating double array list. You can do something like this as well. You don't have to like define your list interface and the contract with this array list. You can do something like this as well. And what you can do, double array list dot add, there is some arrays dot as list. Okay, you can do something like this as well. Double array list dot add. So this is also possible. Like you don't have to like define your list interface here. You can simply create the class, provide the data type that it holds, and create the object. So this is also possible. But in real time example, right, in real time projects, you'll basically do it in the previous manner in which I told you. Like this is a more standard way, because we have basically this list, in this list is already there, this interface is there. So you want to like basically let the any person, if that person reads your code, will basically understand that this person has the knowledge of interface and objects and interface and the class which is implementing the methods of that particular interface. So you'll basically use this method itself, like this particular method. You can use this as well, but I would recommend the first one. So let me know if you have any questions through this, or we'll go through linked list now. Okay.
What you get it for the
Sorry.
double array list?
Yes. Double array list.
Mm-hmm.
Sorry, can you repeat your question? You want me to traverse through this?
Mm-hmm. Mm-hmm.
So that is fine. You can like do this like this. You can like you can just print it out like this. See, I'm able to print this, right? 1.0, 2.0. You can provide one comma. See, 1.0, 2.0. You can like print out like this. Fine. Anyone has any more questions?
No, the result expected for to print out the value of 1,0 and 2.0, 1.0.
So see, your double array list basically holds two double values, right? This is like 1.0
Yes.
and 2.0. So when you use a loop to print it out, it will print out the same, right? It will print out 1.0 and 2.0. Got it? Is it clear? Hello? Okay. We'll go through linked list demo now. So I'll create one main method and then you see, you can do something like this. You can create a list interface. You can create one, you can provide the data type you want to linked list, a new linked list. You can do something like this, or you can also do something like this, linked list integer new linked list. You can also choose to do something like this. I'll comment out the second one because the first one is like more standard, because you are basically showing an interface and you are also showing the class implementation. So this is more standard. I'll provide some documentation as well here. See, now in this case, the list interface implementation is provided by the linked list class, and in linked list I told you when I was showing you the hierarchy, right, that random insertion and removal of elements is possible using the linked list. So now this will be like similar to the array list methods. Now that you have seen the array list methods, right, linked list will be like very much similar to that. Linked list dot add. So see, this is not limited to only integers. You can like add anything. Okay, let me go for a string this time. let me go for a string this time. So now you need to provide some string here. Andrew. So now your linked list basically holds 5 string elements. And what you can do, okay, I've shown you one thing here, right? In this array list class, I've shown you that we can use iterators to print the element. So I'll show you one more thing. We can use something called list iterator. Iterator, integer, list iterator is equal to list of integers dot list iterator. So this was clear to you, right? When we used this iterator. So this iterator was similar to like your for each loop. Means using this also you can basically print out all the elements, and you can like print out the elements from index 0 to nth index. Means you print out using your first index first. Means whatever is in the 0th index is printed first, followed by the index 1, and then whatever is at index 2, 3, 4, 5, and so on. Now what you will basically do here, while list iterator dot has next. Okay, dot has next. So you can print out something like this: list iterator dot next dot next. So you can print out in this manner as well using a list iterator. So I'll show you the difference in in array list and linked list when we will use basically this list iterator. So here you are able to see that the list iterator is also doing the same thing as the iterator. We are again using this has next to check if there are further elements in this collection, and then using this list iterator dot next we are printing out the elements. Now let's come to this linked list demo again. So I have inserted 5 string names in this linked list. Now what I want to do, I want to iterate this, and let me create an iterator now. Iterator string, let's say I name this as list iterator. See, once you have understood the working of this array list collection, right? The methods in linked list will also be similar. Most of the methods will be like similar. You have seen this add method in array list, you have seen this in linked list. Whenever we go for another collections, right, like stacks or set, you will not in stack but in set. In set also you will see this add method. So most of the other collection framework entities will have the similar methods. So I'm using this iterator now, and then I'll use it over this linked list dot list iterator. Now let me try to just a minute. Okay, 1 second. I need to provide here a list iterator. And see, when I do a list iterator here, right, uh, we have seen like using iterators and list iterators in array list. Okay, now what I want to do, I want to use a list iterator here, and using a linked list dot list iterator, what I want to do is I want to print it in a descending order. I want to print the elements which I have at the end, inserted at the end first, and then followed by this Don, followed by Catty and Bob, and then Andrew. Now let me try to print out this. So earlier we were seeing that we were using this next dot next method, right? Now we are using this dot previous dot previous. So what you can basically do, while list iterator dot has previous, so you can print something like this, list iterator dot previous. And let me try to run this. Okay, what is the issue here? Linked list dot list iterator.
I think inside list iterator dot previous you can use list iterator only.
Let me check this once. Uh, uh,
No, can you use for the object list iterator the variable?
Sorry.
I think the variable is list iterator, yeah?
No, this should basically, this is list iterator, and then I've created one linked list here, right? And this is like okay, let me do one thing. Linked list, let's say I have something like this. If I print out like this, no, it does not matter. Basically I should be able to print this in the reverse order. System dot print list. Okay, let me provide the linked list. Not here. linked list dot size minus 1. Does it take the size? Not here. Okay, one thing, my bad. So when you use your list iterator, right, basically you need to provide the size here in this linked list dot list iterator, and you need to like provide the size of the collection like linked list dot size. So when you print it out now, so it knows that this list iterator basically knows that you are pointing at the last element. See, linked list dot size will be basically your last index, right? So your iterator will basically understand that you are pointing to the last element, and from the last element it will check this condition where list iterator dot has previous. So has previous means if your collection still has any more elements, so you'll be able to print now using list iterator dot previous. So this was the catch. I just missed out on this one, linked list dot size. So once you provide this, you should be able to print this in reverse order, printing in print in reverse order. This is clear. Now you can print something like this, like if contains Elvis. Let's say I want to check like if it contains some particular value, if linked list dot contains Elvis. So we'll check this, we'll run this. See, contains Elvis, true, because this was there in our collection. If it was not there, it would have returned a false value. Now let's say I want to do some more operations. I want to do some more operations. Let's say I want to remove some object. Let's say I want to remove Don. And let's say now I want to print the size. Let's run the program now. See, now I have removed Don. So initially the size was 5. When I print the size now, our linked list has only 4 elements. So we'll be able to print 4 now. So there are some more methods here. If you do something like, if you want to get the head of the list, head of the list means if you want to print the front element. So what you can do something linked list dot peak. Okay. Okay, there is like stream dot peak is not required here. I think this does not have this method like peak. Okay, we'll see that when we have the queue interface defined. So you can, if you want, you can like provide the index 0, and you will be able to get the front of the element, like head of the list. Head of the list means front of the list. You can do something like this. So these are some of the methods in linked list. Means if you further go and see linked list dot, you will be able to see like add element in a linked list. You will be able to get the elements. You can add at particular index as well. So adding at particular index. Let's say I want to add something at index 2. So let's say I want to print out the linked list. So when you print out the entire linked list, right, it will print in this format. Means this is your list, and these are the objects which are contained. So see, I entered this at index 2, right? Linked list dot add at index 2. I wanted to add Jerry. So at index 2 we have now Jerry. So if you can do this as well, linked list dot. You can also remove something. Okay, we have already removed. See, these methods we have already seen, like last index of we have seen this list iterator we have seen. Then we can like check like if our linked list is empty or not. So this will like provide you true or false. So at this point our linked list is not empty, so this will provide you a value of false. See, this is false. So similarly you can choose to explore methods here. There are like a lot of methods, so this is the best way to like explore. See, you can do this dot and you will be like getting a lot of suggestions. You'll be getting lot of suggestions. So you can basically choose to. So see, you can also do something like this. You can convert this to a array. So when I say this linked list dot to array, so this was an array of strings, right? So linked list dot to array. So basically you'll be getting a string array. This is like casting it. Like you can cast something like this and convert this to an array. You can convert this to something like this string array as well. So these are like other methods. Similarly, you can go ahead and try to like explore these methods. Explore these methods. You can use a sorting as well. You can use sorting as well here. So we'll see like how we use basically sorting. There is one collections utility class as well. So that basically provides a lot of features for sorting as well. So that is like very handy. So we have seen like array list demo and we have seen linked list demo. Most of the methods in both of them will be like similar, but there will be some added or extra methods in one of them, or there can be like some different methods, but most of the methods will be like similar. So this is about linked list. Let me go to the slide. You are understanding these things, right? Hope you are able to understand this. If you have any questions, you can like ask me. But you will have to like practice these things. Means just go home and like try to practice this. Things will be like easy if you practice these demos regularly. See, these iterators we have already seen. There is one iterator and then there is this list iterator. We have seen both these interfaces, how this can be used. Iterators will be able to, using these iterators, you will be able to traverse only in the from beginning to end, but using this list iterator you can traverse in both the directions, like from start to end or from end to start as well. So these are the some of the things. Okay, there is something called as fail fast and fail safe in Java. So in Java, right, there is basically fail fast or fail safe, and this is one of the interview questions as well, so pay attention here. So what it means, right, fail fast means that while traversing the collection, while traversing any collection, if you get some, and while traversing some of the collection, if you are trying to modify that, suppose I am traversing through the array list or linked list, and at the same time I'm trying to insert an element in the uh, same collection. So at that time I will get some error. At that time I will get one exception. So that will, so that means that if that particular collection is giving me some exception, in that case that is a fail fast behavior. So that is a fail fast behavior. Let me try to show you one demo. Fail fast. Let me try to create one main method. Let me try to create one list of integers. See, you can also do something like this list. So previously what I was doing, I was creating a new array list and then I was like adding with the help of that list dot add each time, right? So you can like use this method as well. So we have something in this arrays.slist. In util package there is one method like arrays.slist. So in the same line you can basically add like these 5 elements. So if you print out the size, basically this will give you 5, and if you like try to print out the list itself, you will be able to print out. See, size is 5. You can also create a list in this manner. Now let me try to show what is fail fast behavior. Now when I use a for each loop, when I'm using a for each loop, let's say I'm using for each loop integer I to print through this list, and what I'm doing, I'm trying to print this, I'm appending it with a space, and at the same time what I'm basically doing, let's say I want to add something like this list dot add. Let's say I'm adding something like 70. Let me try to run now. See, we started getting one exception here, right? Exception in thread main java.lang.unsupported operator operation exception. So Java will provide you some error. It will provide you some error. Like when you provide this, do means what you are basically doing, you are traversing as well and you are trying to modify as well. Let me show this example using iterators as well. Iterator, iterator, I need to create an iterator of integer. Let's say list dot iterator, and what I will basically do, while itr dot has next itr dot next, and I will try to add this, right? Okay, let me try to comment this out for now. See, I'm getting this error, right? Why? Because this will throw an error. This will throw an error because this is fail fast behavior. Fail fast behavior. That is traversal and modification at the same time. Modification at the same time leads to exception. So this is one fail fast behavior. You cannot perform certain modifications and traversal at the same time. So whatever data structures show this fail fast behavior, those will basically throw you the exception. But there are certain collections which are like fail safe. Those will not throw you the exception, like list is new, copy on write array list. This is one of the fail-safe examples. Let's say list dot add. Let's say I'm adding something like 1 2 3 4 5, and let's say I'm creating one iterator. See, these things will be like repetitive. You will feel like I'm seeing the same code, but it is like similar. The way of traversal, the methods in all the different collection entities will be mostly similar. List dot iterator. I will again write down the while loop, while itr dot has next. So itr dot next appended by this space, and let's say here I want to again add something. Let's say I want to add 100 here. Let me try to run this. See, this time I did not get an error, right? See, here I've got an error. I was trying to do something while iterating. I was adding as well. Here also I am doing the same thing. Here also I am doing the same thing. But here I am not getting. So this is fail safe behavior. This is fail safe behavior. Traversal and modification does not lead to exception. So your copy on write array list, this is an example of copy on write array list is an example of fail safe collection. If they ask you in an interview question, like give me an example of fail safe collection, so you can say copy on write array list is an example of fail safe connection. This is a very important interview question. And if someone asks you like provide me a example of fail fast, you can let them know that array list is an example of fail fast collection. There are like other collections as well, like concurrent. There are like other examples as well, like hash maps. This is an example of fail fast collection. So these, did you understand the difference between these two programs? This is fail fast and this is fail safe. So in both the programs we had, in fail fast we were basically using array list, in fail safe we are basically using copy on write array list, and we were trying to traverse and modify the collection at the same time. Array list started giving exception, but copy on write array list did not give any exception. So this is the basic difference. When you don't get any exception, that means that is a fail safe behavior, and if you get some exception while traversal and modification at the same time, then that is a fail fast behavior. So that is evident in the array list example. So this is a very important interview question. You might get this like fail fast versus fail safe, and they might ask you any examples about the same. Now let's see through another example. Let's see, go through another collection. This is set. So set interface we already discussed, right? When we talk about set interface, we want to use it only when we don't want to have any duplicates. Means all the elements that are there in the set interface will be basically unique. So let me try to show this example. So I'll create another package because this is like set of another that interfaces. So I'll name it as collection.framework.set package. Let me close all these tabs, and I will provide you a hash set demo. So we saw that in the collection hierarchy. In the collection hierarchy, basically we had set interface, and there were three implementation classes for that, like hash set, linked hash set, and tree set. So we also saw the difference between all these three. So let's go to the slide once. So in a set interface, you can like add elements, you can remove elements, you can like use this iterator object to iterate through the elements, and then you can like check if the set contains that particular element. So let me try to show you this through a demo. I'll create a hash set demo. Let me try to create a set of integers. So set is the interface here, and set is the interface here, and the hash set is the implementing class. Set interface implemented by hash set class. So let me try to add some elements here. Let me try to like add, let's say I've added some elements here. Now what I want to do, I want to basically iterate through this. So I'll use the iterator, and I will use the set dot iterator. So I'm iterating through this collection, so I want to use the collection name dot iterator, and again I will use the same while loop, while iterator dot has next system dot out dot println. I want to do itr dot next. So let me try to run through this. See, as of now, you are seeing that the order of the elements is coming same, but sometimes you might see in a hash set that the order is coming as different. So it might be in some case that the order might change. So this is with hash set. Sometimes the order might change. Order of elements is not preserved. Here sometimes you will get the same, but there are chances that this can also be different. So you might get a different order as well. So this is okay. One more thing. In sets I told you that this will contain only the unique element, right? Let me try to again add 8 and 8. So once I print this, see, I've added 8 3 times, but still this will print only once. Why? Because the set data structure basically contains only your unique elements. It does not contain any duplicates. And when I do something like set dot remove, if I do something like set dot remove, let's say I want to like remove 8. So let me try to print out again. Let me try to use a for each loop now. Let's say I want to print this I. Now see, once I've removed this 8, right? This 8 was added 3 times. Once I removed this 8, you do not have that 8 altogether, right? You are able to print only from 1 to 7. So this is done. So you are able to remove this object 8, and any number of times you have added this, once you remove this 8, this is removed from the set. Why? Because in set it was like added only once. In set it was only added once, because set contains only your only contains your unique elements. Let's say if you want to check if the set contains any object, and you can do this using this contains method. Let's try to run this demo. So this is like expected to show the output as true, and you are getting the output as true. So this is possible. You can print through this. You can like check through this, like set dot remove add contains iterator clear contains all is empty. So you can use this method set dot size. You can also do something like this. So set dot is empty if you want to print this. So this will basically give you a value of false. So it will check whether the set is empty. So now it will basically return false. So if you like remove all the elements, if you remove all the elements, then this will return you a value of true. Let's say I've removed all the elements. Now if you want to check if the set is empty or not, so now you will get that the value is true because I have removed all the objects from this set. So this is giving me a value of true. So you can choose to like explore further methods by doing a set dot, and you will be able to get all these methods. Also, if you like go click on this, if you do a control plus click on this, basically this will take you to the documentation of this particular class. So it will take you to the documentation of set class and see boolean remove. If you read through this, right, if you read this, you will get to know. So this is like very good thing that Java has provided. You can like go through the Java docs. Once you click on this, you will like you can read like removes the specified element from this set if it is present. More formally, removes an element is such that it is not equal to null or equal to null. So if this set contains such an element, returns true if this set contains the element. So you can like read through this documentation. Any method if you like feel that you did not understand, so you can like basically click on this. You can go, you can basically go through the documentation. So this way you can like get to the definition of each of these methods. So let's go through another slide now. We have seen hash set, we have seen this hash set demo. So let's talk about this sorted set interface. So sorted set interface basically uses the comparator interface, and this will basically sort the elements. So it extends the set interface. So set interface is basically your parent interface and sorted set is your child interface. So sorted set basically extends the set interface, and this has these methods like comparator methods, first, last, and head set, tail set, subset. So these are the methods. Now the tree set is basically your implementation class. So tree set is basically the implementation class. And while I was showing you that collection hierarchy, I had told you, right? So when do we basically use a tree set? So we use a tree set to basically print out the elements in a sorted order. So let's see this example of tree set. So the difference between hash set, tree set and linked hash set is hash set, if you store anything in a hash set, the order of insertion and the order of printing or the traversal that can vary. In a linked hash set, whatever order you are basically inserting an element, that will be preserved, and you use a sorted set or a tree set only when you want to print it out in some order. So we'll see the tree set demo now. Let me try to demonstrate this. So you can choose to either create something like this tree set, let's say integer, or what you can basically do, as we have been seeing, we can like try to create a set interface, try to define the contract, and then provide the implementation class. So this time we will be choosing treeset as the implementation class. So let's try to add some values here. Let's say I've added 50. Now let's say I want to create an iterator over this. And I want to traverse through this. Let me try to print out this. See, the order is now sorted, right? You are able to sort these elements. So this is evident, right? You can basically sort these elements now. So when you inserted the elements, these were in like some random order, like 150,075. But when you print out this, why? Because the tree set implementation is using the sorted set interface, and sorted set interface has methods which basically sorts the element, that will basically sort the element in ascending order. So you can choose to print out the whenever you have a requirement like you want to sort the elements and then print out, you can basically go for a tree set implementation. And additionally, this set will have all the methods similar to the previous hash set, like you can add the integers, you can remove the integers, you can check if it is empty, you can use the iterator, you can use the stream iterator, you can use a lot of methods. There are like you can use the size method, you can convert it to an array. So you can try to go through these methods, and also you can try to go through the documentation if required. So the basic difference between this hash set and tree set is tree set helps you to print the values in a sorted order. Hash set is like when you are not concerned with printing the elements in any order. So in that case, you may choose to use hash set. And when you want to print something in an order, you can basically go for a tree set implementation. So we can also do something. We can also do something like if you want to print out this tree set in a reverse order. Suppose this was in our ascending order. So you want to basically print out in a reverse order. So let's say I'll create something like reverse compare, and so Java provides us some interface. So if you this tree set by default will provide you everything in ascending order. But if you want to like provide your own implementation or your own definition, if you want to like print it in descending order, right, you can choose to do that. So there is something called comparator interface, and that if you like implement that comparator interface, so you will have to basically implement this interface. So when you do something like this, so what you can do is, let's say I want to use something like let's say I have one string, let's say I have another string. Okay, and what I'm basically doing, I am this, let's say we have these objects, and these objects I'm typecasting into a string. Let's say I'm typecasting these objects into a string. So now whatever object value that we are getting, we are converting it to a string by typecasting this one. And what I'll basically do, I will do return like b dot compare to, and I'll do a. So if you do like, if you do a dot compare to b, basically it gives me, it will provide you the ascending order. But if I do this b dot compare to a, like if I do this o2 dot compare o1, so this will help me to basically print this out in a reverse order. So let me try to create this main method, and in this main method I will create the object reverse compare, and what I will do, I will also create a tree set object, tree set ts equal to new tree set. See, initially in the previous tree set demo we saw that, basically we are sorting things in a ascending order. Now we have just written one reverse comparator. So using this reverse comparator, what I want to do, I want to just print it out in a reverse order. So what extra I needed to do, I needed to implement one comparator interface, and once you implement that comparator interface, so you will have to provide definition to this compare method. And if you do a return b dot compare to a, so this will basically sort things in a descending order. And now what I want to do, I want to create an object of this, and I will pass this RCS reference in this tree set. So our tree set is basically now using this reverse comparator. Our tree set is basically using the reverse comparator. So let's say I want to add some things here. So let's say I am adding, and now again the usual thing, whatever we were doing. So let's say I create one iterator, and then I iterate over this tree set. So let me again run that while loop, while iterator dot hex next. So I will print out this, iterator dot next. So let me try to run this one. See, I'm able to print this in a reverse order now. I'm able to print this in a reverse order now. See, what extra I needed to do to print it out in a reverse order. I had to our class has to basically implement this comparator interface, and once you implement this comparator interface, you will have to provide definition to this compare method. Compare method basically takes two objects like O1 and O2, and what we are basically doing, we are, since we want to like compare the strings, so I have typecasted, our agenda was to compare the strings and print it in a reverse order. So I have typecasted this object in a string. This is like typecasting, right? I've shown you while typecasting the primitive data types. So this is typecasting an object into a string, and I have assigned it to a string, and I'm doing return b dot compare to a. So this is basically uh, comparing this particular object with this one, and it will basically print the reverse order. And I have created an object of this reverse compare, and in the tree set object I am passing the instance, or I am passing the reference of this reverse compare, and rest is same. I have added these elements to the tree set, and I'm using an iterator to print over this. So once you do this and run this iterator, you will be able to print this in a reverse order. Let's say I'm just making a simple change now. I'll show you the same thing will print you things in a ascending order. If I do a dot compare to b, if I run it now, it will print you things in a ascending order a b c d e. So our agenda was not this. Our agenda was to print things in a reverse order. So this will print you things in a reverse order. Okay. So this was about tree set. I'll take one more example and then we'll wrap up the class. Then we'll like complete this set interface. So that is linked hash set demo. So linked hash set demo is basically we use linked hash set to preserve the order of insertion. So we will create one set, and let's say I have integer linked hash set. Okay. Set dot add, and I will create an iterator now. Set dot iterator, and I will again write that same while loop while itr dot hash next. So let's try to run this program. So this is like guaranteeing that linked hasset implementation guarantees that whatever order of insertion of element is there, whatever order you have inserted, the output will be printed in the same order. This is always guaranteed. In hash set, sometimes you might see there's a change in the order of the output, but in a linked hash set, you will always see the order comes in the same order. The output of the order will be same. And similarly, this linked hash set also will have the same methods like the add method, remove method, isEmpty, iterator, add all, contains all. This will have the same methods as the previous hash set and like tree set. So it has also similar methods. So basically you understood, right? When we want to use hash set, when we want to use tree set, and we want to use linked hash set. So hash set is basically used when you are not concerned about the order of the output. Tree set is basically used when you want to print out the order, the ordered collection of elements, like you want to print the output in a ascending order or descending order. And linked hash set is when you want to like print the output in the same way in which you have inserted the input. Means if you have inserted the some element in the first, you want to like print it out in the same manner. So I think this was the last topic for today, and we'll continue with collections framework again tomorrow. Tomorrow will be again important because we'll go through a lot of collection framework objects, and these are like very important. These are like important as per interview. These are like important for your real-time projects as well, and this will be like heavily used in real-time projects. So I would recommend you, I'll send out these demos as well. I would recommend that you go through these demos and go through the YouTube recording as well if you have missed out some concepts, but try to like attend the class in person as well tomorrow as well, because this topic is very important. If you have any questions, you can ask, or otherwise we'll wrap up the class for today. Try to like practice as much as possible. Means all the collection classes that we will be discussing will have mostly common methods. So if you get hold of like one or two, mostly it will be like easy for you to get hold of others as well. Yeah, you might have seen that all the examples that I've shown mostly have like similar methods. So you can also use the Java documentation to read. So this is like, this will be very okay. Where do you call compare method? Can you please explain how you create iterator and set dot iterator? I'm not clear this iterator method invocation. Okay, so where do you call compare methods? Okay, so see, whenever you implement this comparator interface, whenever you create your implement this comparator interface, so by default, if I comment out this, let me try to comment out this one. So see, it this class started throwing me some error, right? So it will ask me to implement some methods. So this comparator interface, let's go to the documentation of this comparator interface. See, this is used for basically a comparison function which imposes a total ordering on some collection of objects. So suppose you have two objects and you want to sort them in ascending order or descending order. So what you want to do, you want to use comparator interface in such a scenario. Whenever you want to do some ordering on some objects, you will basically use comparator interface. So this reverse compare class will implement a comparator interface, and comparator interface, whenever you use a comparator interface, So you will have to like override this method, this compare method. So this compare method basically takes two objects, and what our agenda for this example was, we wanted to print out like suppose we are like given like 10 strings, so we wanted to like print those strings in reverse order. So see, this compare method basically takes two arguments. One will be your object O1 and one will be object O2. Suppose we wanted to like do some comparison on integer. So what we would do, we would typecast this O1 and O2 objects to integer. But here we wanted to compare strings. So we typecasted this to string, and that is why this string A and string B are assigned these values. And if you do, if you take the second argument and do this compare to A, so it will basically convert your, it will basically convert it to the descending order. If you do return A dot compare to B, so uh, it will basically arrange the things in a ascending order. So let's go to the documentation of this compare to method. See, if you read this, returns the value 0 if the argument string is equal to the string, a value less than 0 if the string is lexicographically less than the string argument, and a value greater than 0 if the string is lexicographically greater than the string argument. So this method basically returns a value of -1, 1 or 0 based upon what comparison you are doing. So see, if I do a comparison with A dot compared to A, that means it will give me a value of 0. Now if I do a comparison of B dot compared to A, then this will give me -1, and that is used when we want to do reverse order, reverse order. And if I want to like arrange it in a ascending order, I would do this A dot compare to B. This is like normal or ascending order. And what I did, I created an object of this compare class method, and then I had to pass this comparator reference into this tree set, and then it was like similar. I added some elements to this tree set data structure or tree set collection and this iterator. So you were not clear about this iterator as well, right? So what we basically do, I will need to create an iterator, and over this data structure or collection, I need to run this iterator. So ts dot iterator. So see, now we have like 5 elements, right? From line number 22 to 26, I have added 5 elements. So imagine like this, when I create an iterator, it is like a cursor or a pointer which is pointing to this. So it will check in the collection if our collection further has any more elements. So after printing this, it sees yes, I still this collection still has more elements because it is pointing to B. And once this is printed, it the cursor or the pointer goes to this, and it prints C, it goes to D, it prints D, it goes to E. And once this E is printed, when it does while iterator dot hash next, this is a condition for checking if there are any more further elements. So after printing this, it will see that there are no further elements. So this will come out of the loop. So this is how you are basically using iterator. Hope this is clear now. Okay, we'll wrap up this class now, and we'll continue with collection framework tomorrow as well. Tomorrow is a very important day as well, and try to be in the class. We'll cover more topics in collection framework which are remaining. So I'll send these demos. Please practice as much as possible and go through the YouTube recording as well if certain things are not clear. Okay, I'm wrapping up the class today.